Today we're going to be looking at intakes in general. So this is going to be a pretty broad overview of what it takes to get game pieces into the robot, and then we can go and manipulate them and score them in all FRC games. So we're going to see a lot of like the specific details of intakes, then what makes them kind of unique and what makes them different, and kind of all these things that we take into consideration as we're designing them. We'll also see a lot of examples from various robots throughout the years that are using and implementing these different ideas. This is a kind of brief, kind of beginner introduction lesson on intakes. There is a lot more that goes into it as we get to the details, especially of each game, and as we're intaking each specific type of game piece. There are a lot of little details that we figure out throughout that process. These are kind of just general concepts that we can apply to most games as we're figuring out exactly what we want to build. So the most basic part of the intake is what it does. And like I already said, the intake is what we call the part of the robot that's going to grab the game piece. It's normally going to bring it into the robot somehow. Not always, but it's going to be the thing that is the first point of contact and the first bit of control for that game piece to the robot. So that when the robot turns, the game piece moves with it. When the robot's driving around, the robot has possession of that game piece, and we're able to then take it and either launch it out into a goal or pick it up and score it on a rack, whatever we have to do that year, stack it, whatever we're doing that year with the game piece. In the broadest sense, there are two main types of intakes. There are pinch intakes and roller intakes. Pinch or grasp intakes or grabbers or claws or any of those are often what the first idea of how someone thinks a robot would grab something. Partially because we have a lot of times we have an idea of a robot from like sci-fi movies or like an android where we have more like a human form, and like most of the time when we grab things with in our life, we're grabbing them with our hands. So it makes sense that you would want to build a robot to do something the same way you would do it. In general, that normally is not the best way for FRC robots to do it, because we have most of our actions are controlled by motors, and motors are very, very good at just spinning in really quickly. They allow us to make roller intakes, which is the second type of intake, a lot more efficient and easier on the driver, and just in general going to get us more points during the match if we have a roller intake over a pinch intake. There have definitely been certain games and certain times in FRC where pinch intakes worked really well and they were the correct option. That time is probably past with how many motors we have allowed now, with how good teams are at control, how tiny we can package things, the big variety of wheels we have. It's really rare that a straight open-close claw, pinch, intake, grabber, spatula, whatever you want to call it, is going to be faster and more efficient for most teams than building some type of roller intake. If the only intake you can build is some sort of pinch intake, then definitely do that. But if you have a way to build a roller intake that's going to work, it's normally going to be easier to get right, and your driver is going to normally be able to grab more game pieces with it. So for the rest of this presentation, we're really only talking about roller intakes, because it's going to be a very, very rare circumstance that we're going to go down a path of ever designing a true pinch intake. 2019 had a very specific game piece that most teams didn't use rollers to grab. We had some way to kind of extend a mechanism and sort of have a pinch intake, but we knew exactly where the opening was. We knew exactly where the game piece was going to start. So it was one of the few times where you didn't necessarily need wheels. Some teams actually did still use wheels on that, and we can look at examples of that later on. But that's one of like the rare cases in modern FRC where an intake of anything that's going to hold the mechanism, that's going to hold the game piece, isn't using wheels or rollers or some sort of spinning thing. Okay, so as we start looking at roller intakes, which is pretty much everyone that we've built outside of 2019, the basic idea is that the wheels and the rollers are going to compress the game object normally to the floor. If the game object starts on the floor, you're normally driving into the game object. The wheel roller, the intake, is going to be spinning. It's going to push the ball or the game object down, and it's going to kind of suck it in, just like the The roller on your vacuum helps roll things in. If you ever use one of like those roller sweeper things, that's a little bit better because the vacuum also has like actual suction. We're not normally using any sort of suction to grab our game pieces. We're just using that spinning wheels or spinning tubes to bring it in, and then we're able to take it and go score with it is normally what we have to do in most of the games. One of the first concepts of intakes that I want to introduce is the acquisition zone. So it's normally pretty easy to just be able to make an intake that is able to grab a game object in some way and bring it into the robot. So if you just have a spinning wheel, that'll pick up most game objects in some way. You can have a spinning wheel at a certain height, and you can probably play a lot of games with a single spinning wheel of some kind. It's at some point it becomes how optimized are you to allow you to play that game well. And so acquisition zone is one of those optimizations. So how wide of the width of the area, what percentage of like the front of your robot, or whichever way you're going to be driving towards the game piece, are you able to run into the ball and still have it be collected into your robot? And it's really important that it's not just like how far in front of it can it actually touch the roller. So that's something that we definitely learned in 2020 and 2021. I don't have a picture here, but I should probably add it. But our 2020 robot specifically has a little bit narrower of a roller than we could have. We could have made the roller wider. But if we did that, we'd actually end up worse because the ball could touch the roller there. The roller could kind of grab it, but the roller couldn't actually bring it into our robot successfully. So it would actually get jammed, and it would cause more problems than actually doing any good. So we didn't want to have a full width as wide as we could make roller, because the rest of our robot couldn't work with that full width. So the whole process of getting the ball all the way up into your robot, and depending on how the design works, needs to happen for that width to actually be useful. So the answer isn't always just wider is better. The answer is a wider effective area that actually will do the full intake process is what we're going for. And there's normally some amount of optimization there. We could, in theory, design a robot a lot of years that's super wide and super thin. You can do some things with the way the rules work. That's normally not going to be very good because then your robot doesn't drive very well. There's a lot of trade-offs in any of the designs that at some point there's a wide enough intake to be successful, and that's all you really need. You don't have to be optimizing for super wide, not necessarily, like I said earlier, wider is not always better, but you do want enough width that your driver doesn't have to be super precise for exactly where they drive into the ball or cube or whatever we're picking up that year, and that they have some amount of error that they can have to be either too far left or too far right, and when they drive in, the robot and the whole mechanism is still going to bring the game piece in, and then we're able to go take it and score. Another kind of key concept, and a lot of times where we differentiate types of intakes, and that's a lot of what we're going to be talking about here, is like the different categories that we have for intakes and different sort of adjectives we can use to describe them. One of the most simple and kind of distinguished or easy to distinguish for most intakes, if we're just looking at a picture, is they're either over bumper or through bumper. So over bumper intakes, the biggest giveaway is that you won't have any gap in the bumper. So depending on the year and the season, the bumper rules, the fabric and pool noodles that we wrap around a robot, and kind of our football pads for the robot, they're allowed to have specific parts of them and specific widths that don't have bumper sections there. So the corners always have to be protected, but then normally along a certain side, you might be able to have 12, 14 inches. It kind of just depends on exactly how the rules and the kind of the math adds up, of a length of your robot that doesn't have to have a bumper there. So then your whole robot frame, you could have like an H kind of cut out in it, and the ball can just be brought in, or the game piece can be brought in and kind of slid in through that gap. And so that's what a through bumper is going to do, where the over bumper is going to somehow either roll the ball or the game object up over the bumper and kind of roll it along the bumper, or it's just going to pick the game object up outside of the robot and either tilt it back in or twist it back in or do some way to bring the ball or game object back inside the robot without having that gap in the bumper. So as we're looking at some of these examples, we'll be able to point out whether it's over bumper or through bumper when we see some of the example pictures of intakes from other robots. Most of the time, not always, but most of the time when we can, Spectrum's always going to prefer an over the bumper. There's quite a bit of advantages. We haven't done a whole presentation on bumpers, but there's a lot of thought that goes into bumpers, and there's quite a bit of advantages in most games to having a full wrap bumper where you don't have any of those splits or gaps in your bumper. So because of that, our initial plan most years is almost always going to be to have an over the bumper intake, unless there's some reason where we absolutely can't. 2017 was an example where like the rules kind of forced you to have gaps in your bumper. It was really tricky to do anything else. It was possible. There were teams who did it, but you had to get really creative. And we ended up just having a gap in our bumper. 2018, we also needed one. Since then, we've tried to avoid it. It's easier to have like frame problems because you have exposed parts of your robots. You basically have less padding than everyone else does, so you can take harder impacts. It's normally just not as good. So in 19 and 20, we did have full wrap bumpers, and that's normally what we're going to try to do in most games. Okay. Since the very first part of roller intakes, I said that the rollers have to compress the game object normally, so that they actually get a grip and they can like spin it in. That's not always true. I need to probably update some slides and talk about that. There's some other ways to do it. You can have like paddles, and you can have different things that kind of like flap the game object in. But most of the time, you're going to be using some amount of friction and grip, and you're going to be kind of squeezing the game object and rolling it into your robot. To do that well and to have that kind of like compression to be able to like kind of squeeze the game object, either your intake mechanism, like the whole design of it, has to be what we call compliant. Compliant basically just means squishy. It's a nice, fun word for squishy. It basically just means it can give, right? It's not going to be a very rigid object, or it's not going to be rigid. If you push on it, it's going to squish in a little bit. It's going to deform. It's going to compress, and it's going to allow some other object to kind of take some of that room. So if our intake is compliant, that means we're normally going to have a rigid game object. So in a few games in the past, we've had like plastic totes. We've had milk crates in 2018. We've had some rather firm balls that didn't want to squish very well. So if we had a rather firm, heavily inflated ball, you may want to have a compliant intake. So something on the robot was going to move out of the way for the game object to be able to still roll in. On the other hand, if you have a very squishy game object, so a lot of times when we have these like foam dodgeballs like we've had the last 2 years in 2020 and 2021, you don't necessarily need to really consider how much of your intake itself is going to move or squish or do anything, because you can just squish the ball. So our intakes in 20 and 21, the ball is 7.5 inches, somewhere in there, 7 inches. It's a pretty big ball, and we're able to squeeze it down. I think the smallest gap it goes through in one of our intakes is like 4.5 inches. So we're squeezing it pretty tight. We might even get down a little bit lower. And the ball can do that pretty easily without any issues. So we don't have to worry too much about the wheels or the rollers we're using squishing. We don't need to have any part of our intake moving around for the balls. We can just kind of squish the balls into a small space and still get them fully into our robots where we need them. So yeah, the big takeaway here, and I need to probably add this to the slide, is if you have a rigid game piece, you want to have a compliant intake. If you have a compliant game piece, you can have a rigid intake, and it still works well. Rigid intakes are normally easier to design. They're normally cheaper. You don't have to worry too much about all that flex. You don't have to build any of that in. Okay. So let's start looking at some of the kind of general concepts of what these roller and these intakes look like. So this is 254's intake from 2020. This is a pretty prototypical modern day FRC intake. this is what we consider top rollers. So the spinning parts of the intake here, so all of these three rollers, they're only going to be on top of the game object. So the game object will be on the floor. This roller will spin it in, it'll compress it against the floor, and then compress it against the bumper. Then as it's going up, it'll transfer to this next roller, then to this next roller, and eventually be inside the robot. So this is the same way that our 2020 and 2021 robots work. They're both top roller intake robots. The rollers just spin the ball or other game object. The same thing could work maybe with footballs. The same thing can work and has worked with even frisbees and other objects. Like they're a little bit trickier with rigid objects. We'll talk about that a little bit later. But there are ways to make them similar types of top rollers work with other game objects. When we're designing this, one of the big things is we're always worried about however the path of the ball is, that it always is touching a roller. So it's always actually getting pushed along the path that we want it to. So if we have some like what we'll call often a dead space or a dead spot where the ball can get stuck and it ends up not touching a roller. So that was one of the problems that we had in one of our 2021 robot, and one of the things that we need to be kind of actively working on. It causes some problems at Texas Cup, was depending on how the ball intakes, there were a few spots where it could kind of get, and then none of the rollers were actually touching it, and it was just going to be stuck there until we like moved the intake or shook it around or something like that. So ensuring that the rollers always make contact with the game object is a super important part of intake design, especially on top rollers where you have the opposite side not spinning or moving or anything else. It's just kind of a rigid part of your robot or just a static part of your robot. Okay, another way that you can do intake design is by having top and bottom rollers. So this robot over here is 1114's 2014 robot. In this configuration, it's actually in its like scoring configuration, but this whole claw here tips down so that this wheel gets very close to the floor, and then this roller right here and this wheel are going to be on top. And so the 2014 game object is this big 24-inch ball. So as this robot, when it has the claw down in like its intake mode, this roller spins and grabs it first, and then it sucks it in, and then it has it hit this roller, and it brings it all the way back into this cage area to hold it in that ball. So it has a top roller and a bottom roller. This normally is going to work better with single game piece games. You normally don't see it too often in a multiple game piece game where we have to collect, say like you have a game piece or a game where you have to hold like 5 balls like we did in 2020. In 2014, you were only ever allowed to hold 1 ball at a time, and that's normally where you're going to see intakes like this a little bit more. Not always. Like there have been robots in multi-game piece games where you can get a roller down on the bottom. It's just normally a little bit harder to deploy. It becomes a little bit more complicated. You can imagine if you tried to put a roller down here towards the floor, it's just difficult to actually have it start inside of the frame perimeter. So everything has to start like behind the bumpers. It's difficult to figure out how you would start it up here, have it come down. You have this weird problem of like if you're trying to like turn into a ball, if a ball's coming in from the side, the bottom roller doesn't allow that as easily. So just in multiple game piece games, we have these like long, kind of long rollers that are really wide rollers. It doesn't work nearly as well as having the top and bottom, where single game piece games, it works pretty easily and is very effective at getting the game piece exactly where you want it in the robot. Sort of a variation on the top and bottom roller is the side rollers. So this is basically the similar concept, just rotated 90 degrees. Again, this is going to work pretty much exclusively for single game piece games. There are times probably where you could do a multi-game piece game with side rollers. I can't think of a good example robot off the top of my head that's done that. It's probably has happened. Here is it's nice because it works better with variable height game objects. So if you have, so like in 2018, there were different configurations of the milk crate depending on which way it was rotated. So you didn't necessarily have to get the height exact right for a top roller. You get a little bit of a wider acquisition zone since the rollers can kind of spin the game objects into the center here. So if you only touch it with one, it'll still kind of, it can pull it into the middle a little bit. It's definitely easier here. In 2018, we had these like rigid milk crates. So we built some compliance into the intake so that these claws could kind of spring back. There was pneumatics with them as well. So that allowed it to suck in and grab that rigid plastic box that it had to hold in here. Yeah, it's side rollers work pretty okay. They're pretty game specific though. If you ever have to stack something, so like 2015, side rollers made a lot of sense because you were bringing in a big tote that you had to bring in, and then you were going to stack a multiple. So grabbing those from the side made a lot of sense instead of trying to grab it from the top. It also didn't have like a very smooth top surface. So if you have an object that has different characteristics depending on the side of it you're touching, the sides may be smoother. It may make more sense to use it that way. Yeah, so those are the kind of the different roller configurations for most of them. One of the things that's a little bit sort of a combination of some of these is what's sometimes known as a floating roller. And basically what it allows it to do is allows the roller to move as the game piece is coming into the robot. And this is another way that you can basically include more compliance in your intake. So several teams did this. This says 2017. This is not 2017. This is 2013. I'm going to fix that right now. So when you have these like frisbee intakes, didn't get it at the right spot. I thought I did. All right. So when we have when we're actually going to be intaking a frisbee, which is a very rigid disc, unlike these foam balls, it also doesn't roll. It's really tricky to figure out how you're going to get it to go up and into your robot and like pick it up. So they have a good explanation in this video that kind of walks us through it. Let me go ahead and get this started.
All right. So can you tell me about how this kind of elastic system?
Yeah. So frisbee's going to come from the bottom down here, and what we have are two kind of activated bars, if you want to think of it. And because it's got to go up this ramp here, but the side view of a frisbee is more like a straight edge, these fit to the change in shape as the frisbee goes up this ramp. So anywhere the frisbee is in this, it's always getting the push of these belts. So this is just like a Pepsi belt, like in a bottling company. And then these are the regular Vex wheels, but then they're both spring-loaded, as you can see, and shoves it up 6 inches of space. It goes from horizontal to 1.5 feet, raised it up, back to horizontal up here just by jamming it into this guy. So
that's really elegant.
Okay, so yeah, so that floating roller is kind of that bottom one is the one I was discussing. They also have a floating belt, which is basically just like a bunch of individual rollers. You could imagine you could do this with multiple wheels instead of a continuous belt. So the floating roller means that you're able to have like a pivot point somewhere that's able to have the roller itself move. It's going to be sprung down in some way so that the object can force it to give itself a little bit more room. It can like tilt it up or down like they do here in this example. And we'll see the roller get pulled up and down there. So he's pulling against a spring. So as the disc goes under that, the spring's always putting force on it, so it's always allowing it to keep moving it up this wall, even though it's now like further away from this bottom edge. It's now like touching back here somewhere, but the disc is still moving up and eventually touches that belt. And so anytime something is called like floating or anything like that, it basically just means it's sprung down in some way instead of just rigidly mounted. Like we would most of the other rollers on our intakes. So again, yeah, so this is most useful for rigid, sort of odd-shaped objects. There were some more teams that did similar things in 2018. 18, where we had a rigid gear, which we'll see some intakes for in just a little bit. But any sort of like hard plastic game objects that you need to try to push up a ramp or anything like that, some type of floating or spring-loaded rollers are going to help a lot. Okay. One of the questions we get asked a lot is whether to use wheels on an intake or some sort of roller or tube style intake. And a lot of times it depends on the design itself. So sometimes it depends on the width. So if you have a really wide intake, so this is our 2021 intake. Actually, we built this in 2021 for the off season. And this has just polycarbonate tubes that have some 3D printed end caps in here, and we're able to make really long rollers that way rather easily. This example from Team 7506 here has just a lot of these little green wheels. These are called compliant wheels because they're kind of squishy. They have these gaps cut into them so you can squish them really easily, and they give your intake compliance, which we talked about earlier. Neither is necessarily wrong. Both of these work pretty well. They have their advantages and disadvantages, just like most things in robots. We're just kind of tweaking what makes sense for us and what we like to do. Most of the time, this is basically you're just making a roller out of lots of wheels. So you can have a simple hex shaft, which is really easy for a lot of teams to use. Hex shaft is one of the most common types of rotating parts and just parts on any FRC robot. A lot of teams use it all over the place. So by having these wheels that you can just slide over hex shaft, it's super easy to make a roller like this with kind of the motion components that teams are already using. One of the reasons we like to use tube is it actually just saves us a lot of money. So each of these little wheels here is normally about $5. You can sometimes get them a little bit cheaper, maybe $4. So they get pretty expensive pretty fast, right? If you have 10, 15 of these on your robot on a shaft, you now have a $40 or $50 shaft. 2 feet of this polycarbonate tube is $10, maybe $15, with some 3D printed parts that basically cost nothing. We can say we can be a fourth, a fifth the cost of a roller like this, which doesn't necessarily matter. But as we're making a lot of them for changing sizes, if we're doing all sorts of things, if we're beating them up, if we're making spares, it's convenient just to have this stuff stocked. And for us, it makes maintenance a little bit easier. We don't have to take on and off a bunch of these different rollers. If we have to like swap a shaft or anything, we're not taking on and off all of these wheels. We're not worried about any individual wheel breaking ever. The individual wheels kind of on a shaft system do have some advantages in that you can tweak intake performance based on where on the roller you are. So with our kind of tube roller, we can do that a little bit based on like putting grip tape or any sort of other like friction material. It's going to make it a little bit stickier or grippier, depending on the game object. We've done that in certain games. But with these, you can change the spacing of the wheels. You can change the type of wheels. You can change the diameter of wheels. There's all sorts of things you can do when you have like individual segments. That doesn't mean you have to control all of those variables though. So if it only works in a specific way when you have a specific set of wheels in a certain order and a certain spacing, that means every single match that you want it to work that way, you need to have it set up like that, which can be sometimes difficult depending on what exactly you're trying to set up. Where normally with our rollers, as long as they're basically going to be the same. The polycarb is super durable. It doesn't crack or break and take impacts really well. And we've been using some version of a polycarbonate roller for the last 3 games, 19, 20, and 21. And they've come to work pretty well for us. But it's very possible that in the next game we'll have a bunch of wheels because that's the thing that makes the most sense and is most efficient and can give us the best chance of scoring lots of points and winning matches for that coming game. So it's always nice to have the other examples and the other options and kind of understand how other teams do things in case we need to do it next season. One of the last things about just sort of normal sort of intakes is how they actually release game objects. So in a game like this, where we have just balls being brought in and then put into some other part of the robot to be sorted or to be launched out or whatever they're doing, you're normally not really worried about the release method, because the release method is just the furthest most roller of your intake, sort of spitting the ball up into your robot, and it's going to sit there and get taken and get used in your robot somehow. In other games, such as like 2014, so like this for this robot right here, we're not actually it doesn't ever really leave the intake very much, so it'll get brought back into here, but we still have it's going to go out the same way it came in. So 2014 had some robots that were built like this. Any of the pick and place games, so similar like 2018, we're going to suck in a cube and grab it, and then when we go to score it, we need to somehow be able to release that cube. And there are a couple different ways to do that. So one is we could just reverse the intake, right? If we spin the wheels one way to suck in a game object, we can spin the wheels the other way to kind of shoot out or roll out the same game object. And that works. And that's what a lot of teams, kind of their initial idea normally is. The issue with this comes, you end up with less control or less precision. So if I want to place a cube in an exact certain spot on, like, say, a bunch of other cubes or like a stack of cubes, if my only way to shoot the cube out is to kind of reverse those rollers, I'd have to get really good at knowing where that cube's going to end up. Maybe I have to go really slowly and reverse them super slow. And be like backing up at the same time. It can get really complicated if I'm trying to place a cube in the exact spot with just spinning the wheels out. So instead, we'll often have some way to hinge open our intake and basically just remove the compression between our rollers and the object and allow that object to fall away or allow us to back up, allow our robot to back up. And this is normally done by hinging one of the arms of the intake roller. So if we have a top-bottom roller or side-to-side, it could be both of them. Sometimes with just a top roller, you're just hinging the top or the bottom. So maybe you have like a different object below it that's not a roller sometimes holding the game object in place, and you can hinge that part. And it's just very helpful to very gently and precisely release the object. So that was definitely a big advantage in games like 2011 and 2018. To have that kind of hinge open mechanism definitely was helpful to a lot of robots those years. That it wasn't necessarily it wasn't very easy to see that just from the game animation. If you go back and watch those, kind of watch what we're told at kickoff and see the game animation, and then you actually go see how the game is played, the teams that had this hinge open had an advantage. Okay. Singulating intakes. So sometimes we want our intake width to be really wide, but we want the game object to end up in a certain spot. So for a lot of these intakes, like both of these, if the ball's over here on the left, it's going to be over here on the left once it gets into the robot. There's nothing kind of forcing it to the center. There's nothing forcing it to one side or the other. So once it's in the robot, we kind of have to deal with where it is and kind of sort it out once it's in the robot. So both of these kind of work the same way. Just wherever the ball is in relation left or right, it's going to be in there once it's in the robot. Singulating intakes, what they're trying to do is make it so the ball ends up in the same spot in the robot, whether it comes in on the left side or the right side or the middle. We're going to have the ball come in at the same spot into the robot. They basically allow for that really wide acquisition zone, so we can acquire the game piece across the whole front of our robot, but then get it precisely located for whatever our scoring mechanism is, or whatever the next part of our robot is. So we kind of combine those two things, so we don't have to have an extra sorting device or anything like that. Again, this is a little bit of a opinion. There are teams who have the opposite opinion. We definitely designed this way most of the time, is that this works best for single game piece games again. When you have multiple game piece and singulating intakes, when you're trying to like sort the game piece into a certain spot, you run the risk of having your intake jam, and you have to figure out how to make sure it can handle that if you have a game piece coming in from the left and right at the same time, and they're both trying to like go to the center, it's very possible that you're going to get some sort of jam. One has to move out of the way of the other, something like that. And so in 2020, there were a lot of different teams who were building singulating intakes, and they definitely can work. And it really just depends on how you're driving and how you approach balls, because you don't want to be grabbing two balls at the same time with a singulating intake unless there's some more advanced way to kind of deal with that jamming problem. So there are two really common versions of this. One of the most common nowadays is the vectored intake wheels. It's just another word for mecanum wheels, which are often used on drivetrains. They started being called vectored intake wheels back around 2014, 2015 when they first started being used on intakes. Started mostly as a joke. Now it's not really a joke anymore. They're sold this way. So these 3D printed ones down here are made by the Thrifty Bot, and they're sold as vectored intake wheels. They're not designed to be driven on at all. They're just designed to be used for intakes. And the main advantage of them is they have these 45-degree rollers, similar to like Omni wheels, except they're just turned 45 degrees. And because of that, they, instead of just driving the ball back and up, so like it would want to climb over the bumper, there's a part of the wheel as it's spinning that's actually pushing the ball sideways. So in this example here, so this is the 2016 intake from 118. These front rollers can kind of grab the ball and shove it back, and then once it's under these vectored intake wheels, they're trying to push it back and up the bumper, but since it can't quite go, through that tiny gap, it's a pretty big ball that year. It's like a 10-inch ball, I believe. I could be wrong there. It's going to sit here, and that vector is going to allow it to slide sideways. And then they have normal wheels here in the middle that push it through the bumper. So this is our first example of a through bumper intake. So that ball is going to go between the bumper gap here and then into the rest of the robot. So especially for things like this where you have that bumper gap, it's super useful to have this singulating intake so you don't have your intake only be as wide as that bumper gap. So you can get a bigger acquisition zone, and you can still have the through bumper gap that you wanted to, and you don't have to do any sorting on the inside of your robot. It's all done externally, kind of using your bumpers as like this backstop to slide the ball into place. And this year I was actually loading a catapult on this robot, and then it would launch the game pieces out of from right here behind this kind of plate that you see. You do need some sort of backing. If you just have a shaft of vectored intake wheels, like if these were all vectored intake wheels up here, they would help a little bit. The ball might go at a little bit of an angle towards the center, but largely it's just going to slide pretty much straight back. But when you run it into a wall while it's still in contact with the wheel, that's when you really get that slide sideways motion that they're kind of designed to get. The other common way that we do the same thing in FRC, and this one actually started first, so is a design called the CD7 intake. So this was a design that was used by Chief Delphi, Team 47, who no longer exists anymore, but they're the namesake of the form that we still use, Chief Delphi. They're now merged with Husky Brigade to become Wings of Fire, so the team that Wings of Fire still exists, and they are the combination of these two older teams. And they developed this intake back in the 90s, maybe early 2000s. I don't exactly remember the year. And since then, it's been copied numerous games to sort of do the same thing as the vectored intake wheels, except we didn't have to have small mecanum wheels at the time. So this one, it ends up being a little bit more complex because you have to have shafts rotating perpendicular to your main intake shaft. So we have a main intake roller here. This like black tube is spinning to get the balls in. This is Citrus Circuit 1678's 2016 robot. So this whole thing would come all the way down. The ball would get grabbed by this roller, and if it was off to the side, it would get shoved under these belts, and the belts would slide the ball to the center, and then would get held right here, getting ready for it to be launched out. They had a flywheel spinning back here to launch it up into the goal. So there's a few different ways that you kind of design this, but you do have to somehow get this perpendicular motion. So some teams will use what are called bevel gears, which are the same things that we have in our swerve drive that we talked about last week. So you can get that 90-degree motion or 90-degree rotation of motion out of them. Some teams will also just have a whole second motor. There's a few different ways you could do this same type of thing. But you do have to make sure you're keeping all of these belts together and all of these rollers. It does add quite a bit of complexity. It adds quite a bit of weight. We've never built one. We've made some kind of rough prototypes before in the past. But depending on the game, this might be a necessary idea. Probably not. Most of the time, if we can and if we need to do the same thing, we'd probably use vectored intake wheels. But it is very useful to know that this concept exists. Okay. There are a couple passive devices that get added on to intakes that help, depending on what the game piece is and exactly how we're going to intake the ball. One of them is known as a kicker bar. They're basically just stationary rods, sometimes a plate, that kind of sit between the intake and the bumper that change kind of how the game piece is going to get compressed in that area. So sometimes you don't necessarily want to use the bumper itself as your compression because the bumper is super compliant. It's just made of pool noodles. It can squish a lot. So depending on what the game object is, maybe you don't want that squishing. Maybe you want a rigid object back there. Putting some type of metal bar or metal plate might help make the whole intaking process more efficient so you can actually get the balls up into your robot or the game pieces up into your robot. Another thing that they do, depending on exactly how they're designed, is with certain game objects and depending on how your bumper works, if you're driving too fast or if the robot or if the game object can be squishy, it might start running under your robot, which can be very frustrating. You can't drive as fast across the field if you're trying to avoid the game object all the time because you're worried about them getting stuck under your robot, or just driving over them makes you not as quick because you're bouncing and stuff after that. So kicker bars can sometimes go down kind of below your robot and kind of act to push the balls out of the way, push the game pieces out of the way without getting them stuck under your robot. I already talked about it. They can control compression and kind of just make the whole intake process smoother. They do get a little bit tricky because they aren't always easy to deploy. Similar as you're talking about having a bottom roller or bottom intake roller, just getting the geometry right for how the whole thing starts sort of up into your robot and how you can flip it down can be a little complicated. Sometimes they're separate. I need to find some more pictures to make this concept a little bit clearer. The second type of passive devices that get added to intakes are often called like a dustpan. And basically, this is just a very thin piece of plastic that slides under the game piece and allows you to kind of do the rest of the pickup process. So this happened, there were a lot of these dustpan style intakes in 2017 where you had to intake this rigid gear that was kind of like this flat, sort of boxy cylinder-ish thing. It didn't have very curved edges like a ball does, so it was really hard to roll up onto something. So this piece of thin Lexan right here was the dustpan on 3310's 27 gear intake. You can basically like sand the edge to make it an even like sharper edge so it can get under any sort of object. And so as the roller touches the gear, it brings it up onto this piece of Lexan, and then it can lift it up and hold it and kind of pinch it between the dustpan and the roller. And then when it goes to drop it off, it can just reverse the roller and release the gear when it needs to. So this worked quite well for them. And a lot of other teams had similar type Lexan dustpans to be able to intake that gear that year. And it can work with other totes and things. Some teams used it in 2018 to intake the milk crates. Anytime you have sort of an object with like flat edges instead of a ball, a dustpan can be super helpful to get them up and acquired, and so you can actually lift it off the floor. Okay. So we're going to go through some of the types of deployments. We're already at Comes close to an hour, but this shouldn't take too long. So this should take about 15 more minutes. So when we're talking about deployments, we're basically talking about how the intake can go from stored up inside of the robot at the start of the match. So again, we have to kind of be inside the frame perimeter, which is inside of the bumpers, basically. So at the start of the match, this intake here, this is like all this blue frame, all of this would be flipped up on the pivot point here in red. It would be up over this portion of the robot, and then when the match starts, it's able to come down when they actually want to intake balls and suck them up. So this is the most common intake type for most ball games, anything like 2020, 2021, even 2016, 2012, any of these same similar types of pickup balls, launch them out. Front low pivots are by far the most common. They're also like the easiest. They're normally the lightest. And in general, if you can package one and it makes sense, they're pretty easy to work with, and you can normally get an intake geometry that you want and have a very effective intake. So that's one of the reasons why they're used a lot, is they just kind of work without having to do too much complications to the rest of your robot. So this is the same, a version of this is what we have on our 2020 and 2021 robots, or something similar, at least part of it for 2021. We'll look at 2020 specifically in a second. Another way that you can do the pivoting for the intake is you can have a rear low pivot. So the intake for this robot's actually way up here. Oh, this is actually a good place to see a kicker bar. So this is a kicker bar right here, this tube that's running across. So when this whole mechanism lowers down, this tube ends up pretty close to the floor back here. So this helps get the ball sucked up onto the bumper and get brought up into here where it needs to get sorted. And so these rear low pivots, basically what they really are doing is they just change the storage geometry of where we're putting the intake when it's folded up into the robot. So here it's basically the topmost part of the robot. It's up above all their entire like launcher mechanism, because they wouldn't have any room to have a front low pivot because it would want to be stored kind of in the same space as their launcher. So instead, they move the pivot farther back. They have these long arms, and they can store it up higher. Oftentimes when you do this, they're also able to take advantage of these longer arms and integrate them in with other mechanisms. So this intake arms here also integrate part of this robot's climber, since it's already pretty high on their robot. They extend more tubes up, and this is how they grab the bar in that game, so they can combine their intake mechanism with their climber mechanism to save some weight, make the packaging all work, so you don't have to have like a whole nother mechanism kind of built in here that's also going to flip up. You can kind of use some of the same motors and pneumatics and anything else to accomplish multiple tasks. So the rarest of the intake styles is anything that's like a high pivot. So normally this can't actually be very functional because you can get the intake to take up very little portion of the robot. So here you see it's like basically a flat line to be able to store the entire robot or store the intake inside the frame. You have this flat line running down to the roller here. The pivot's way up here. And when you kind of push it out, it's going to draw this sort of arc, right? It's going to kind of come up and out and be able to grab the balls. In this case, this is a 2019 robot from Team 33, so it's grabbing these orange balls. These are quite a bit taller than the bumper, so it's okay that the intake almost moves up as or does move up as it's going out. You wouldn't want to use this if you had to get the roller like lower than the intake, so or lower than the bumpers. So if this roller needed to go down below the bumpers for say like the 2017 balls that were really small, they were only 5 inches, which is lower than our bumper height. A high pivot wouldn't work very well because the whole roller is moving away from the ball, so it's never going to be able to grab them unless you had some other part of it that folded out or did something else weird. So if you already have a tall robot, And you can put it up here. There is times where this may make sense. It just sort of depends specifically on the game. But this is definitely going to be the hardest one to find examples of. This is one of the only robots off the top of my head I know that uses it. One of the other very common ways to extend intakes is what's called a 4-bar linkage. So these other three that we looked at were just simple pivots. They had a bar and a single pivot point. The 4-bar linkage is where you start getting into slightly more complex linkages. You add some more hardware back here, like so all of these bars and things don't actually do anything to help the ball come in, but they do change how the intake is stored and how it's able to be deployed, like what orientation you have those two states in. So depending on how you need to fit something into a small space, maybe there's something else on top of it. Maybe you're using it for some other reason that you don't want it to actually flip 90 degrees or more or change the angle at all. You want it to stay parallel. You can make a 4-bar that allows it to stay parallel like this one does. And yeah, so it really just allows for different packaging and different states when you're stored and when you're extended. We're not going to go too far into 4-bars into this. There's a lot more we can talk about into how the linkages work, how we design them. That's a whole nother slideshow and presentation on how to do that. But really, it's just useful to know that sometimes if we can't quite fit it and have the flipping work, putting in some of these, putting in an extra kind of link here instead of just having the single bar pivot will allow us to solve the problem in a different way. One of the things that is important is you can kind of see here that this is basically forming a parallelogram. So in this case, we do have this like parallel 4-bar. So that's going to keep this sort of flat wall of this intake flat to the ground the whole way through its movement. If we have non-parallel links or non-like symmetrical links, you could have one of these arms like a little bit shorter or a little bit taller. You can change how this rotates as it moves through its motion. And that can be really important in the design as well. So just knowing that's an option is helpful as we start thinking about how intakes work and things for whatever game we're going to get in 2022. One of the last ways we're going to talk about to extend an intake is a linear slide. So this is basically just a sort of a version of a drawer. So the intake here on 148's 2019 robot, the roller is actually right here at the front of the robot to begin the match. And then they have pneumatic cylinders that push it out along these rails that just push this roller straight out without having any sort of height change at all. So since you don't need, you don't have to flip, you don't have to do anything, you can just slide it out on these rails to get the intake deployed. It'll suck in the ball, and then it can just it can just slide right back in behind the ball. It's very useful when you don't need that, when you don't need to take up any vertical space. It does require a little bit more room across the robot, right? They have this entire rail here. It needs a much larger or longer pneumatic, actually. You need to be able to push for more distance than when you're just pivoting something in and out. So that often means you end up using a little bit more air when you're moving in and out. So they can work. Normally, if we can make a pivoting intake work, we're probably going to try to do that first. They're normally like kind of the default. We did look at doing sliding intakes in 2019, similar to what they did, but it worked out to where we didn't need to, and we were able to kind of make a pivoting thing work for us. In our 2021 robot, this is one of the first times we've ever done something like this. I don't know of another team who's done something exactly similar, but we were trying to get some of the advantages of the 4-bar and being able to like store the intake in a certain way while still being able to use it as a single pivoting intake during the match, but we weren't able to completely get that single pivoting to fit inside of our frame perimeter. So we actually added a second pivot to the intake. So this blue box down here and this first red pivot is the same thing as just a front low pivoting intake. This pneumatic cylinder here pushes it in and out, and this arm moves up and down. But this green and other red circle up here are actually a spring deployed intake. So at the beginning of the match, they're stored. They have like basically a lock over a portion of the robot here, and so the roller is basically just stored over that thing, and it's held in by a part that's on the roller. When we spin the roller at the beginning of autonomous mode, it undoes that kind of latch, and this portion tips down to be pretty close to perpendicular with this portion. So this front roller sticks out from the robot, but it basically stays over kind of our bumper area. And then for the rest of the match, it acts as a single pivot intake, just the same. So we're able to get some of the advantages of a 4-bar while keeping it a little bit simpler without having those extra links to worry about and extra pivots and things. We just have this one built in here, and then we just have to remember and set it up every match to store it, which can be a little complicated too. So there's advantages and disadvantages of both, and there's kind of trade-offs through all of this, right? There's different ways to make any of these systems work for a robot. We're always just trying to figure out how we can optimize our choices along with the choices of every other subsystem so everything kind of fit and everything can function and flow together and work well, be relatively easy to maintain, not have any failures on the field. All of those things are what we're kind of looking at as we're figuring out what our design is going to be, what our final design is going to be each season. How do we actually deploy it? So either pneumatics or motors to actually deploy it. Most of the time for Spectrum, whenever possible, we're going to deploy intakes using pneumatics. The vast majority of our intakes are deployed using pneumatics in most of our games. 2018 being an exception, the intake's just mounted on a big arm, and that's how it gets out of the frame. Most of our other intakes are pneumatics from 19, 20, 21. Those are all pneumatic deployed. Largely pneumatics versus motor is kind of the same trade-offs. Some of them we talked about in some of our control stuff. Pneumatics don't need to use one of our motor spots, which those are limited. So we only have so many motors we're allowed to use on a robot, but we're allowed to use unlimited pneumatics. So by having a mechanism use pneumatics that can and it's relatively easy to use pneumatics, we make sure that we're not taking a motor from some other mechanism. Pneumatics are usually only good for 2 positions, in and out. For our intake deploy, that's normally all we want. We want it to be out intaking balls, or we want it to be stored inside of our robot. And then if we do use motors to deploy an intake, you do have to worry about getting the gear reduction. Our motors all spin very fast, so we need to have some amount of gearing to make sure we can control it and position it well enough that we have enough torque to actually move it up and down, lift it the whole way, and keep it controlled. We'd have to do a little bit more programming with a motor to actually get it to make sure it's hitting the spots we want it to do. Sometimes that can be very useful if by moving it to different spots, we're able to score in different ways. Maybe there's different heights we need to score at. That might be something we need to do, and that can help us. But a lot of times, if we're just trying to push the intake either out or into frame, and we can use pneumatics, we're normally going to. We're not going to go through this tonight, but I did include it in the slide deck. It's a really good video. So if you want to start looking at how we actually design these pneumatic deployments, Adam Hurd, who was on 973 at the time, developed these ramp series, and he has a really good video on how we design linkages using sketches. The video is done in SolidWorks, but the concept is exactly the same. All the sketches exactly the same for how we're going to do it in Onshape and how we do it in Onshape. And we'll talk more about how we actually designed our 2021 and 2020 intakes at another time. But that video is pretty much exactly the process that we use to do this.